We're studying IGCSE Chemistry, and we're starting reversible reactions and equilibria, division 3. Now, in the last class, let's recap what we did. We did rules for Le Chatelier's principle. We finished concentration, temperature, and pressure. Now, the main thing after this is concentration, temperature, and pressure. And yep. And after that, we looked at Haber process and contact process conditions. Ayan, since you have finished the chapter, do you know everything about Haber process and contact process?
Haber process produces ammonium. Contact process produces ethanol.
Not really, no, not. It's not like that. We'll go through it one more time. Just a second. Let me try. Let's copy this and paste it.
Good afternoon.
Good afternoon, Anas. How is your day?
Pretty good.
Pretty good. That's nice. Now, just let me share the last class with you. We just recap it. Now, Anas, tell me, what did you do in the last chemistry class? Quick.
Yesterday?
Yesterday. Yesterday, I think day before yesterday.
Oh yeah, the day before yesterday we did the Le Chatelier's rule, and then we did some questions on reversible reactions.
And anything about Haber and contact process? Do you remember?
Yeah, I remember the thing we did. Wait,
That's good. All right.
Can you repeat?
I said, do you remember about the Haber process and the contact process? The conditions.
No.
No, you have not written the conditions. Check your notebook.
1 second. Contact processes? Oh yeah, I have that contact process. Yeah.
Okay, let's look at it. So the first thing is concentration. This one right here.
Are temperature has to be 450 degrees Celsius, pressure has to be 2 atmospheres, and gases has to be vanadium 5 oxide. The source of reactant, sulfur dioxide, burning sulfur in air, or roasting sulfide ores. Oxygen comes from air. Stage 1 is converting sulfur into sulfur dioxide. Stage 2 is converting sulfur dioxide into sulfur trioxide. Stage 3 is converting sulfur trioxide into oleum, H2S2O7. And stage 4 is converting oleum into sulfuric acid.
Now we saw that there's an alternate stage 3. The alternate stage 3 is, instead of converting, first, what happens? First, you convert sulfur into sulfur dioxide by burning it, combustion. So sulfur with oxygen reacts, makes sulfur dioxide. All right, clear. Again, then sulfur dioxide again reacts with oxygen to make sulfur trioxide. Now we know that this sulfur trioxide is an acidic oxide, and when it reacts with water, makes sulfuric acid. Well, if it does that, why don't we directly add sulfur trioxide to water and get H2SO4? That's the alternate stage 3. Sulfur trioxide is added to water that produces acid mist. Now this is the equation for that. SO3 plus H2O gives us H2SO4. Now we're getting H2SO4 directly. Why do we have to make oleum? H2H2O7. That's kind of strange. But the issue right here is underlined, produces acid mist. Now this right here is what acid mist looks like. This giant cloud of mist is what is produced. If you add sulfur dioxide directly to water, it produces a very exothermic reaction, and it's very violent, and it's going to make an acid mist. That is why we don't add directly the sulfur trioxide to water. Instead, we add it to H2SO4, which we already have, to make a very concentrated form of H2SO4. That is called oleum. Yes, Manvi.
What does the acid mist consist of? Because we're using all of the elements and everything already to make H2SO4, right? So
acid mist is H2SO4.
oh,
So it's a mist of H2SO4, right?
okay.
It's written right here, H2SO4 acid mist. Basically, what happens is it becomes like a vapor form, like a gaseous form,
Okay.
because it's very violent, it's very hot. Therefore, it becomes like a gas.
Yeah.
It does cool down and then does settle, condense after some time, but it's very dangerous, especially if it's left in air. If it touches your skin, it's going to burn a lot. All right. That produces acid mist of H2SO4. Now you have to write all of this. Manvi, have you finished did you finish all of this in the last class?
Yes, we did write all of it.
All right, then Ayan, I want you to take a screenshot of this, quick.
All right, you can continue.
One more time, just a second. Now take a screenshot.
That's
Now next thing, Haber process. Ayan, start reading.
N2 plus 3H2 plus 2NH3 gives 2NH3. The conditions are temperature must be 450 degrees Celsius, pressure 200 atmospheres, and the catalyst is iron.
Now this temperature 450, just a second, is actually not exactly 450. In the exam, in the mark scheme, they're going to give you a range. So if you write anything from 400 to 500, you'll get the correct marks. But sometimes the range can vary. Sometimes they ask you for 450. Sometimes they say that it should be more than 430 or something. So the best bet for you is to directly write 450, because in any condition, that's always going to be correct. That's why I've given you this answer. And that's usually, so it's from 400 to 500. So in the exam, if they give you an option to choose 400 for Haber process, you should go with it. If the other options are, let's say 200 or 100, this is the best, this is the closest answer. Now continue, Ayan. Continue.
The source of reactants, nitrogen comes from air and hydrogen gas comes from methane. CH4 plus 2H2O gives CO2 plus 4H2.
All right, so now this is this hydrogen gas. Where does it come from? It comes when methane reacts with water to give us CO2 plus 4H2. Now these are, well, okay, first tell me, have you done this in school, this equation?
No, sir, I think so.
Manvi?
I think we have.
We have it.
Okay. All right. Now, so if you
Pretty
have
sure we
that,
have. It's just the Haber
We
process.
didn't do the chapter itself. We didn't do an organic chemistry in school.
then that's not very good, because right now I'm trying to practice papers, but before that I have to teach you, since your school has not gone through most of the things. The one issue I'm facing is that you have a lot of gap knowledge, or knowledge gap basically, right? Which we have to cover. That's why I'm giving you everything here. Ayan, take the screenshot. Shreya, take screenshot of this, the whole thing. Now, I'm not asking you to write it right now, because you'll have to watch the recording for the missed classes, which I expect you to do in your free time. And from those classes, you have to make the notes of those classes as well. Taken screenshot?
So the Haber process is done in order to release energy, right?
No, it's done to produce. It's for formation of ammonia. Why is it done?
Okay.
Not ammonium salts, not nitrogen, not energy, but formation of ammonia, NH3.
Okay.
The ammonia, we'll see why we need ammonia. It's well, why do we even need sulfuric acid? Well, all of them have uses, and the past papers and the exam, Cambridge is going to ask you that. So I'll give you the
Sulfuric
uses.
acid is used to dry gases, right? That could be
It's a
one thing.
dehydrating agent, right?
Yeah.
Dehydrating agent. That's one use. Other uses are
Drying
it's used for
agent.
bleaching. Yeah, drying agent, dehydrating, drying, same thing. Now, another thing is, it's also used for making a lot of things. It is also used as a bleach. You also get SO2 from it, which is also used as bleach and used as a preservative. I'll tell you all of that later. Now, start reading from here, Manvi.
Yes. Chemical reactions in equilibria 2, agenda, Haber process, contact process, and
Not that part,
fertilizers.
actually. Skip that. That's an old class. Read from here. Reason.
Okay. Reason for choosing the conditions for Haber process. Conditions, temperature 450 degrees Celsius, lower
All right,
temperature favors.
stop
Okay.
just a second. Now, what are we doing? Well, I gave you the conditions, but more important than memorizing the conditions are understanding why we use these conditions, because that is what all the questions are going to ask you. Only few questions will ask you the conditions, and you can easily write 450. That's not a big deal. But they will ask you, why do we use 450? And that's what we're looking at right now. Now, Haber process is N2 plus 3H2 gives 2NH3. Memorize that by heart. And delta H is negative. That means it's exothermic. Now, since it's exothermic, that's a key part in temperature. Now, what do we know about temperature, Manvi? What temperature favors exothermic reaction?
Lower temperature.
No, lower temperature, exactly. Higher temperature for endothermic. So lower temperature favors exothermic reaction, but 450 is not really low, is it? Now let's read from here. Shreya, read from temperature.
Temperature 400 degrees Celsius. Lower temperature favors exothermic reactions, but higher temperature increases rate of reaction. And so to have a faster reaction, we take a compromised temperature of 450 degrees Celsius.
Now this word compromise is a key word, which is given in your syllabus booklet, which if you read it, the word compromise is key, because all we're doing is we're doing a compromise. We have two options: get either a fast reaction or high yield. High yield. Now, well, there's a choice. Should I get a fast reaction or high yield? The thing is, even if I get a high yield and the reaction is very slow, well, that doesn't really benefit me because it's very slow. This reaction, Haber process is very slow. That is why to increase to make it faster, to have an actual economic, let's say, profit, you have to increase the temperature and have a compromise between the yield and the speed of the reaction. Now let's rewrite some of these things. Just a second.
Wait, exothermic mean?
Exothermic means a reaction which releases energy, heat. A reaction that releases heat to the surrounding. Anas, is that clear? Now start writing from here. Conditions. Reason for choosing conditions of Haber process. The first condition is temperature. Write the whole thing in your notebook. Tell me when you're done. Now after favors, you need to write favors yield of. Lower temperature favors yield of exothermic reaction. Then write, but higher temperature increases rate of reaction.
What does endothermic mean?
Say that again. What is endothermic?
Yeah.
Endothermic is a reaction that takes in energy or heat from the surrounding. So endothermic takes in heat exothermic gives out heat. Exothermic makes environment hot and it feels hot. Endothermic feels cool because it's going to absorb heat. Now, I think I've asked you to write it in the last class. I'll give it to you again one more time. No worries. You should revise your notes. Now, after this, you have to write, but even though higher temperature reduces yield of movement. Tell me when you're done writing. What is the meaning of yield, Anas?
1 second.
Anas?
I'm trying to find it.
It's not in your notebook. It's right here. Now read the definition of yield on the whiteboard.
How much product is made?
All right, yield is how much product you're making. So the more product you want, therefore you'll have to make the reaction favor. If you want to make more product, then the reaction should go forward. And so if the reaction goes forward, the yield will increase. More product is made. Is that clear? It's how much something is made. Quantity. Now this endo-exo is from a previous chapter. I'm just revising this for you so you know what it is. If someone does not know, you should also write these definitions for endo, for an exothermic reaction. Shreya, are you home now? Are you writing?
Yes, I've started.
Started. Manvi, how much? Finished?
Yeah, we wrote all this last class.
No, you did not write this one in the last class, no.
Yeah.
Not this one, the condition.
Okay.
And the reason for it. So first condition for Haber process is why we need the temperature. Because even though lower temperature favors exothermic reaction, it does favor, lower temperature does favor it. But however, higher temperature is going to increase the rate of reaction. So we take it as a compromised temperature. Write the whole thing. Tell me when you're done.
Also, I have a doubt. When we're doing chemical energetics and suppose we have to calculate the bond making, bond breaking. So suppose it's an suppose it's an addition reaction of a polymer. I mean of an unsaturated hydrocarbon. So will all the bonds break?
All the bonds. Now, yes. So you have to look. Whenever you're doing chemical energetics, you have to break all the bonds and form all the bonds again. Is that clear? So
Yeah.
always break all bonds, form all bonds, and subtract bond forming from bond making. That will give you the enthalpy change.
But
We'll
then
do
the
that.
other day in my exam, I only did it for the CC double bond that broke, and the answer was wrong.
Now, one thing, Manvi, there's the stakes for IGCSE are quite high. Now we are just on chemical energetics right now. I'm trying to finish revising most of the things. And when you get to solving papers with me, you'll realize that there are questions out there that are much difficult than what you have done already. Because my goal is not to just do papers or questions from past papers. Our goal is to do difficult questions, right? Which are going to test you.
Yeah.
That is quite important. So first finish this. I hope you're done. Ayan, how much have you finished?
Sir, I'm carrying pressure.
Because compared to A levels, it's much easier to get full marks in IGCSE. Now, you should take this as an opportunity to aim for full marks, not just A star. Because the colleges you'll be applying to, even in India or abroad, will look at your IGCSE grades. And if you say you got a full or perhaps even a 95 percentile, they will be, let's say, impressed. A lot of yours, yes.
One question. Do we get like our scores as well, like out of 160 or 130 or whatever?
Yes, you will. And your
Yeah, we
university
do.
will ask for it. Those are called raw marks. What are they called, Shreya?
I don't know.
Raw marks.
Oh, draw marks. Okay, fine.
Also,
You'll have to ask
is it necessary? Is it necessary to take FLE in order for the I certificate, or can we also take ESL?
You can take ESL as well. It doesn't make a difference.
Okay.
You have to take a language subject, fine?
Yeah.
As long as, okay, so in FLE, actually doesn't make a difference at all, because even if you want to apply to some college or something, English is not is not that important. It's what is more important is your marks in maths, physics, or whatever main subjects you're hoping for. As long
Yeah.
as you get an A star, they're happy.
Okay.
Answer.
Finished? All right. Anas, how much? Finished? Tell me.
Almost. Wait. Do we also have to write high pressure favors reaction? Stuff like
Yes, you have to write that as well. So Anas, Ayan, continue.
that? Okay.
I'm giving you reasons for all the conditions. And in the book, it's not really that organized. It's like a story in the book, and it's quite difficult to make sense of it. That's why I'm giving it everything in an organized manner. All you have to do is understand this, memorize it, rewrite the same thing in the exam. When you practice questions, you'll realize how the answers are exactly like this. Neha,
Sir,
good evening. Yes,
good
Neha.
evening, sir. Actually, sorry to interrupt. I just joined to inform you, sir. Sorry for not joining the classes. Actually, I've been infected with dengue, and I'm not
Alright.
feeling well. So yeah, I'm on bed rest and I'm on medication. So yeah.
All right. Then just take rest. Don't worry
Yes.
about anything. You can I'll upload all the recordings for you, and you can take an extra
Yeah.
class with me later to catch everything up. Don't worry at all.
Yes.
Rest
Yes.
right now. Okay.
Yeah. Thank you so much, sir. Thank you. Bye.
High pressure favors. Okay. Now, who is done with the temperature part?
Yeah, I'm
No,
done.
I got that. Okay. It's pretty easy. Yeah.
Right. There's only two lines here. Higher temperature increases. It reduces the yield, but however, it does increase the rate of reaction. So we take it as a compromise. But writing, you have to write all the things, especially the second paragraph and the third paragraph. This is key. But sometimes they'll only ask for this. So you'll have to look at the question based on the question. Now, I want you to stop for a second, put your pens down, and Anna, start reading from pressure. The rest of you focus on the whiteboard.
Wait, where do I start reading from?
Pressure.
Pressure. Okay. Pressure 200 atm. High pressure favors yield of reaction side with lower number of particles. A very high pressure will be expensive and dangerous. So we take 200 atm.
Now, okay, so high pressure favors yield. Look, we saw the rule. We've done this in the last class. You will have to watch the recording. We know that already the reaction, higher temperature always favors the side with less number of particles. So since you have 4 particles here, 1 and 3 of hydrogen molecules, so this will be 4. We don't count this 2 over here. We don't count that. We only count the molecules. How many molecules we have? So 1 nitrogen molecule, 3 hydrogen molecule, that's 4. Over here, we have 2 ammonia molecule. So therefore, it's 2 as the ammonia is the side with less particles. The higher temperature will favor the production of ammonia. But the problem is, you can increase the pressure to, let's say, 1000 atm. That's possible, but it's not really cheap and it's very expensive. And you have to write one more thing here, that the yield is already, let's say, very good. So we don't have to take that much of a high temperature because it's expensive and dangerous. 2 marks, two answers, 2 marks in the exam. Now finish writing. Ask me if you have any doubts. Manvi, any questions?
Wait, I have
No, not really.
a unrelated
Yes, Anas,
question.
ask me.
It's not related, so
Go on.
okay. So is it true that Cambridge added like marine science to the syllabus?
Yes, marine science is there. Yes, you can study it. One of my friends did take the subject. Yes, marine science. But one thing, it is not reputed and it is not highly accepted yet. So you will be better off just studying biology if you want to do marine science, because most of the things in A-level biology are exactly the same, right? And A-level biology is a requirement, while marine science is never a requirement. It's an additional subject.
So do I
Similarly,
have to do bio?
yeah.
Because I'm not interested in bio.
If you're not interested in bio, then you don't have to do it,
Okay.
right? Which kind of course are you interested in studying in university?
Mm, what do you mean? Yes.
Say that again, louder.
Wait, what do you mean? Like,
What kind of degree do you want to do in college? What course?
I don't know.
Don't know. It's fine. You can think about it, and you can discuss later with me as well if you want. Now finish writing this pressure and temperature. Quick.
All right.
Once you're done writing, you guys will know what will come in the exam. So all we have to do after this is practice questions. Shreya, can you hear me?
I can hear you.
All right. Tell me, what was the last chemistry worksheet you finished or homework you finished?
The last thing I did was stoichiometry.
Stoichiometry. Now I'm going through the list of worksheets and who has submitted all of them. And there's quite a lot of people
Oh,
missing.
we had metals. 1 second. When was that? Oh, 2 days ago. Okay, makes sense why I did do it. Yeah, stoichiometry I have.
Okay. No, Shreya, you have not submitted it. Right? Only two people have done it out of 6. And that
1
is
second.
quite a disappointing sight. Okay, check after the class.
Just
Not
give
right
me
now.
like 1 second because I did scan it and I did try to upload it, but probably didn't happen. 1 second. I have the PDF. I'll upload it right now if it's fine.
Not right now. After class. Finish
Wait,
writing on the board first.
I do it.
Okay. Now, first tell me, all of you, what is the progress? Manvi, where are you?
I've written everything.
Everything. Ayan,
Sir, I finished a while back.
A while back. Now you have to tell me this, right? Because you're wasting your own time,
I know I did.
not my time. You did? All right. Anas, have you finished writing?
Yeah.
Shreya, Anas finished pressure. The next thing we're looking at is catalyst. Manvi, start reading.
Yeah, catalyst, iron, does not affect equilibrium yield, but increases rate of reaction by decreasing activation energy.
Now the word decreasing activation energy is 1 mark. All right. Now if you just write increases rate of reaction, you'll only get half of the mark. So you have to also write that it decreases the activation energy or provides an alternate pathway. Now finish writing this as well, catalyst, iron.
How does it decrease activation energy?
All right, I'll show you. Just a second. Now activation energy, let's say by providing an alternate pathway. Now you don't have to write, you should write it, but you don't have to memorize it. And if you do, it's good, it's better for you.
I'll be right
Just a
back.
second. All right, Anas. Now look at this. If I show you a drawing on the board, Shreya, Anna, Ayan, the rest of you also finished writing, even Manvi.
Yeah.
Look at this. You have a hill. Perhaps you have a hill like this. Okay, you have point A and you have point B. Fine. And look, you have this is a hill, perhaps.
Yes.
Now this you are perhaps a cyclist going on the thing and you're sitting on this. Now, okay, that's one way to go from point A to point B, right? Now I'll show you another way. This is another way of going from point A to point B, perhaps something like this. Now, which do you think, Manvi, is easier?
The second one?
The second one. And that is what a catalyst does. It provides an alternate pathway, which reduces the energy required for the reaction to happen. So this is reactant, A is reactant, and B is product. Go from reactant to product. There are many ways you can react. One way could be, let's have a H2 molecule right here. This is H2. So this, both of these are H, perhaps let's say hydrogen and hydrogen, that's H2. Now, okay, that's something. And I have N2 here. Now I have 3 of these, and I have to react them. The thing is, there are some ways to add or to join them together, which are, let's say, the second route compared to the first one. You can do it in both ways, but the second route with catalyst, second is with catalyst, and that's easier. So therefore, if something is easier, that will require less energy. Is that clear?
Yes.
Any questions?
No.
Right? Just write this in your notebook. Tell me when you're done. Shreya, questions? Ayan, questions?
I'm done.
No, sir. And
No,
I'm also
sir.
done.
Done. Okay. Now let's start the next one. Reasons for choosing contact process conditions. Temperature is the same as for Haber process because both of them are exothermic, right? Both are exothermic, same as Haber process. However, pressure is a bit different. High pressure does favor the yield of reaction side with low number of particles. This is the reaction SO2 plus O2 gives us, it's a reversible reaction to SO3. Now this is the reaction. On this side, I have 3 particles or 3 molecules. Over here, I have 2 molecules. So this is lower. And if I increase the pressure, this will go forwards. Fine. But why am I not using 200 atmosphere here? Compared to Haber process, it was the same thing. But over here, we're using 2 atm only, not 200. The reason is the yield of SO3 is already very high. So there's no need to increase the yield anymore. It's very high already. Therefore, I don't use much of a high pressure. Is that clear? Any questions?
No.
Yield is already very high. Therefore, we take, and high yield is expensive and dangerous. So we take 2 ATM. Write this, all of this, quick. Or the whole thing actually.
Isn't it 200 ATM?
200 is for Haber process.
Okay.
That's why it's different. It's not the same as Haber. Over
Yeah.
here, we use low pressure because the yield is already high. In Haber process, the Haber process reaction is very slow. The yield is less. So we have to do quite a lot of things. But SO3 over here is already very high. So there is no need of increasing the pressure.
Yeah.
Now, when you're done with this, the chapter will be over. There's a few more things which I'll give you as additional things, which are not really from this chapter. They're from environment, but they're usually asked with equilibria. So we look at that. Those are uses of SO2, uses of ammonia, uses of sulfuric acid. And then the chapter will be over. We start something more difficult in the next class. Now, Manvi, which chapter do you find difficult? In organic chemistry, right?
Not really. It's not difficult. It's just I haven't studied it in detail.
Right. We have to study all the chapters in detail.
Yeah.
Now,
The thing I find
yeah.
most difficult is probably ATP. When they ask you why do they run it with distilled water or something?
You do it with distilled water because you have to remove any impurities and any leftover acid, because that will interfere with your reaction.
Yeah,
Right?
but they ask us what happens when you what ions are removed when you run it with distilled water and stuff.
Right. So you look at the question. That's easier. When we do it, you'll find everything easy. Don't worry. The only problem is that we have to do it first. That will take time, right? Yeah, we're finishing one chapter in every 2 classes. So I think we'll finish that quite easily. And ATP is exactly everything is from theory. There's nothing new, except the 2 tables I gave you, right? Those are the only thing different from theory. Now, Shreya, what is your main difficulty in chemistry after this?
Okay, my main difficulty in chemistry, I'd say electrochemistry, the whole thing.
Electrochemistry. Ayan, yours?
Probably organic.
Organic. Right. All right.
Yeah, electrochemistry is pretty easy.
Pretty easy. All right.
Yeah,
Now, have you finished writing this? So if organic is difficult, then we're going to have a test for organic this weekend. Is that all right?
Yes, that's perfect.
Now, I would say organic is actually more difficult than the rest of the chapters, because it's
I
not really
actually
difficult.
find it to be easier than acids and bases.
I see. It's just that you have to practice. Perhaps, Manvi, you haven't done all the questions. Because before you joined, we were doing past papers. We did a lot of tests on organic, and nobody's,
Yeah.
I think, scored more than 75% in my test.
Oh, okay.
The highest, I think, was about 67, I think, which Ayan and Shrey got those marks, or 70 something in organic.
Oh.
Now, finish this. Can I move on?
All right, I'm back.
And let's take a screenshot and start writing. The rest of you tell me when you're done. Now, all of you, Ayan, Shreya especially, you were absent the last few days because I understand you had exams. But moving on, I want you to be present in all the classes. Things are getting much more serious now. Your exams are literally 1.5 months or 2 months uh, in the future. Things are much more serious now. The stakes are much more high. You have to start learning everything on your own. Ask me for doubts. We're also finishing chapters we'll finish chapters quite quickly now, right? So I can't expect any absence.
Yeah.
Manvi, Anas, Claire.
Yeah.
Guys, I think you must be finished now. I'm going to move on. I need
All right,
progress
sir.
report quick.
I'm done.
Anas,
Yeah. I'm done too.
Okay, almost. I'm on the second last one.
second last. Take a screenshot, Anas.
Okay. All right, I took it.
Done. Okay, just give me 1 second.
Yes, sir.
Now start writing from here. We're looking at the next thing we're looking at is fertilizers. Fertilizers is directly related with ammonia and also with sulfuric acid. Now, what are fertilizers? Well, we know what they are. They're used to increase the yield of crops, to give nutrients to crops. Now, start writing this. Fertilizers. Write after that, write main components. Nitrogen, phosphorus, and potassium. And that is why they're called NPK. NPK. Nitrogen, phosphorus, and potassium. These are the main components of fertilizers. Write this, tell me when you're done.
Okay.
Finished?
One second.
Done.
And after that, also write examples. Common examples could be ammonium salts.
Is there an example of fertilizer?
Yes, example of fertilizer. We'll look at more examples, but this one is main, ammonium salts. Why? Because they dissolve easily. In water. But there's another problem of this. Since they dissolve easily in water, they can cause a lot of problems such as eutrophication or the algal bloom. We'll look at that later. Just say, instead of writing dissolve easily, write very soluble. So if anything has ammonia in it, it is going to be soluble. Shrey, have you done the solubility rules?
Solubility, salt solubility?
Salt solubility rules, yes.
Yes, I have. I remember almost all of them, but
Okay.
I don't remember the table. I know whatever's in our textbook.
Right. I think you've done this with me in class, right?
Yeah, we
you've
have.
done
We
it.
have covered solubility.
Manvi, have you done it?
No. Oh wait, I do know what salts are soluble and what are insoluble. Like all sodium,
Yeah.
potassium, and all are soluble. All nitrates are soluble and all that.
So we had a class long before Manvi joined.
Yeah, I know. I remember. I know that. You should know that, all right? But I just want to know if I have to revise this again. Now, Manvi, can you tell me,
Yeah.
is barium sulfate soluble or insoluble?
It's insoluble. All sulfates except calcium, barium, and lead sulfate are soluble.
All right. And what about silver chloride?
It's insoluble. Silver and lead
Alright.
chloride are insoluble. Yeah.
What does soluble mean?
Dissolve in water.
Or
Alright,
anything
let's
else,
go
right,
forward.
sir?
Soluble means there's not 2000 water, right?
Now this, finish. Hayward process, uses of ammonia. Contact process, uses of sulfur dioxide. Uses of sources of sulfur. And finally, uses of sulfuric acid. Quickly finish writing.
What are we writing?
Hayward process, uses of ammonia and uses of sulfur dioxide, sources of sulfur, and uses of sulfuric acid.
There's only one use of sulfuric acid.
No, there's more. I'm just trying to remember.
Oh, okay.
The next use
Okay.
is
I'm yeah, I'm
Guys.
almost done. Give me a sec.
explosives. Now 4 is enough for sulfuric acid, right? They will usually just ask you to, all one. And the preference goes, so the preference is from the beginning. So first say dehydrating agent, then say fertilizer, then say explosive, then say dye.
What is NH3 plus H2SO4? Like, what does it give us?
It gives us an ammonium salt. It gives us ammonium sulfate, which is itself used as a fertilizer, right? It's basically a salt of ammonia. So there are many ways of getting, how do
Yeah.
we get a salt? We react a base, ammonia is a base with any acid. You can react it with HCl or
Yeah.
with sulfuric acid or phosphoric acid. Usually we prefer phosphoric acid because it has phosphorus in it. And plants need NPK, nitrogen, phosphorus, and potassium. Now, when you're
Yeah.
done with this, I don't think there's anything else to do here.
One second. I wasn't done with the never mind.
Just a second.
No, sulfuric acid uses.
Yeah.
I only wrote until dyes. One sec. Oh, it is only till dyes. Never mind.
Only till dyes. Ion done.
Almost, sir.
In ammonia, I want you to write making explosive as well. Well, TNT, the N in TNT is nitrogen. The N in TNT is nitrogen. And that nitrogen comes from ammonia.
And what's the T?
The T is tri, and the other T, I have to try to remember, just a second. Yeah, all right, it's called toluene. Now, you don't know what this is. It's an organic compound.
Okay, fine. So nitrogen toluene. Trinitro
Nitro toluene. TNT. Finished, Manvi?
Yeah.
Now, I think I if you compare the way I'm teaching you and this how school goes about chapter A's, can you name any differences?
A lot, because in school we just don't go through chapters.
All right, Shreya?
Uh-huh.
Any difference in the way that I'm teaching you and the way that your school goes about in the chapters?
A lot different.
I see. All right. Now, one thing is I don't ask you to go through the book always. I only ask you to
Yeah.
read the book when it's necessary, and I only give you information which is coming in the exam. And whatever
Yeah.
you're writing in your notebook is only necessary, right? So no unnecessary stuff.
Yeah,
I
the
hope that
teacher
helps.
at our school usually skips topics, so yeah.
All right. Finished. Ayan, how much have you done?
Oh, sorry, I finished.
Finished. Anas, any questions?
No questions.
Now, Anas, I enjoy your questions. You can ask me as many questions as you like, right? Don't ever hesitate. Now, next, okay, look, we'll go through the stages of contact pressure one more time. Did you write have you written the reactions in your notebook already? The equations. I think you have, right? Check. Have you written the equations? Even if you have, write this one more time. Because these wordings are important.
Do you write that?
Yes. These wordings are important. So finish writing this. And last thing is write the question, why is sulfur trioxide not directly added to water in contact process? This is a question directly from the past papers. It's 2 marks. One reason is it makes acid mist. Second reason is violent or toxic. It's not enough to say it's an acid mist. You have to say, well, it is an acid mist and it is also toxic or dangerous or violent. And if they ask you to give the reactions and describe the reaction, it's a clear 4-step process. Make sulfur dioxide, make sulfur trioxide, make oleum, then dilute oleum with distilled water to make H2SO4. So you should add distilled over here, distilled, not any water, but distilled water. Finished? Progress?
Almost.
Now below are more examples of acid mist. Now Manvi, can you see this one? The black spray over here?
Yeah.
That's more accurate. That's how it looks. It's like when you add something into boiling oil and it just splashes around.
Yeah.
That's what happens. Finished?
Yeah, do we write why sulfur trioxide not being cleared?
Yes, you should. Now,
Oh,
Anas, did you write all of this? Did you write the steps here?
oh no, I'm writing that right now. I'm on the third one.
Now, this is more important than the equation because I think you have written the equation once.
Yes.
This is more important.
Okay. Let me write.
Just 1 second. Right, nothing else.
Also, in case I need to like refer to some other stuff in the future, can you like send me this board or whiteboard?
Yes, I will.
Okay.
I will be uploading everything. I've been quite unwell and a lot of work
Yeah.
right now. But so whatever we have done in class will be in GCR. Fine.
All right.
Hopefully this week, the end of this week, right? Weekend.
Now, is class done?
Class is done. Just a second. We'll just go through one question.
All right.
Right. Now the other is, have you finished writing? Ayan, tell me.
Yes, sir.
All right. If someone hasn't, take a screenshot and then finish writing.